Okay, so today we're going to do Unit 6 Notes number 3, which is factoring when A is 1. So today what you will be able to do is you will be able to factor a polynomial. Oh, let me spell that right. Into two binomials. We're only going to be able to do this when our A is 1. Next week we'll cover whenever A is not 1. So it says identify the solutions of the following quadratic. Solve algebraically. So what we want to do is we want to solve for our x, and we're going to graph it. So we have 3 sets. We have 2, x minus 4, and x plus 3. 2 equals 0. X minus 4 equals 0. And x plus 3 equals 0. That cancels. We get x equals 4. And we get x equals negative 3. So these are our solutions, 4 and negative 3. So we're going to graph those on our line. 4 and negative 3. Okay. And then if you were to graph this in the calculator, so make sure you guys utilize your calculator to check your work. It's going to be a great tool just to make sure you're getting your right solution. So if you're going to type it into the calculator exactly like you have it, the only thing you really need to know is whether it's going right side, which directions it's going. In this one, I can tell you it's going to be going up. So you're going to have a min. So it's going to go all the way down and then back up. And the reason why is because my A value, or this number in front, is not negative. So what about something like this? So we have 2x squared minus 2x minus 24. So this one would be a little bit trickier to graph because it's not in our factored form. We would have to think, okay, how are we going to get that in there? Now, if you were to graph this on a calculator, we would have 2x squared minus 2x minus 24. And if you graph it, you can see, oh, the x-intercepts are negative 3 and 0. So this would actually, so we have negative 3, and then we have 4. If I said negative 3 and 0, I'm sorry, you guys. And this would be our quadratic. You guys, what do you notice about those two? They're the exact same. That's because this equation and this first equation we started with are the same. This is just regular form, and this one is in factored form. So we're going to talk about how we are going to be able to go from the unfactored form to the factored form. So whenever we're looking at this, we're going to talk about our A, B, and C value. So it says factoring when A equals 1. So first we're going to go over our quadratic, which is y equals a x squared plus bx plus my c. So your a, b, and c will all be replaced with numbers. Your x squared and your x are going to same. So all of the ones we're factoring today, the a value will be 1. So you will just have an x squared. Okay, the example we're going to use today is going to be 3x squared minus 3x minus 18. So you're like, well, Mrs. Gilbert, you told us that the a value, which is this number in front of the x squared, is going to be 1. Well, it will be, but we have to go through our steps. Our first step is check for a GCF. So is there a variable I can pull out of each term? No, because there's not an x in every term. So is there a number I can divide 3, 3, and 18 by? Yeah, 3. So sometimes you will have to factor out a GCF before we can actually factor it. So we're going to pull out our 3. We're going to be left with x squared minus x minus 6. So now we're going to go on and we're going to factor everything that's in parentheses. So we're going to create 2 parentheses with that. So the first step is we're going to set up our parentheses. So I'm going to have 3, and then I'm going to get 2 sets of parentheses from the x squared minus x minus 6. So how do I do that? And this kind of goes back to our warm-up. What 2 numbers added together get our b value? So our b value is going to be the number in front of the x. And then multiplied together get our c value, which is our number on the end. So how I am going to write it is what plus what equals -1, and what times what equals -6. These 2 numbers that I put in, so this number, and this number have to be the same. So what are your multiples of 6? You have 6 and 1, you have 3 and 2. Which of those added together are going to give you 1? Well, you're going to have to subtract because one of them has to be negative. So you could do 3 and 2. One of them is going to be positive and one of them is going to be negative. So you're going to have -3 and a +2. Now, sometimes you'll kind of have to wiggle these way around. So it says fill in the parentheses. So remember, we're going to have x as the first term, and then we're going to have -3, and then we're going to have +2. So let's write our finished product down here. So we're going to have 3, x minus 3, x plus 2. So that is how we do our factoring when a is 1. So we do what plus what equals our b, and then what times what equals our c value. Okay, going on to the back page. Kind of review, how do we check our work? We just, let me get my pen on. We distribute. Okay, so our first example, we have x squared minus x minus 20. So our a value is 1, so we can start off with what plus what equals my b value. My b value is going to be right here, which is -1. And what times what equals my c value, which is the -20. So you may have to think a little bit. So -20, we have 10 and 2. That wouldn't give you 1. You have 4 and 5. Oh, that could give me 1 because one of them has to be negative. If you want to add them together and get negative, your bigger number is going to have to be negative. So it's going to be -5 and 4. And then I'm going to take those and put it in my parentheses. So I'm going to have x minus 5, x plus 4. Now we're going to check our work. So we're going to distribute. So I'm going to kind of do this over, well, we're just going to create our box. So we're going to have x minus 5, x and 4. You get x squared, -5x, 4x, and -20. Combine your diagonals. So you get x squared minus x minus 20. Is that what we started with? Yes. So we did it correctly. So you can always check your work on these. Or we're going to go on to solving. We'll go on to solving later. Next one, I have 3x cubed plus 9x squared plus 6x. First, my a value is not 1, so I always have to think, can I pull out a GCF? So can I pull out a coefficient from 3, 9, and 6? Yes, you can pull out a 3. Now, can I pull out an x from every term? Yes, because there's 1 in every term. I can just pull out 1. So I'm going to be left with x squared plus 3x, because I did 9 divided by 3, which is 3, and I had 2 x's, pulled 1 out, so I'm left with 1. 6 divided by 3 is 2, and I already pulled out that x, so that's all I have. Then you're going to factor. So what plus what equals my b, and what times what equals my c. So to get your c, it's going to be positive, so either has to be 2 negatives or 2 positives. Well, I want to get a +3 right here. So I'm going to do, it's going to be 2 and 1. Those are the only multiples of 2 anyways. So my final answer would be 3x, x plus 2, x plus 1. Okay. Next, I have 2x squared minus 4x minus 16. First, is there a GCF I can pull out? Kind of think about it. You can pull out a 2 from every term. So you're left with x squared minus 2x minus 8. So then you're going to factor. What plus what equals negative 2? And what times what equals negative 8? So this, you can do 8 and 1 or 2 and 4. It'd have to be 2 and 4. And that 4 is going to have to be negative because you want to get a negative 2. So you're going to have 2 times x minus 4, x plus 2. That would be my factored answer. Okay, let me know if you have any questions over either of those two. Okay, let's go down. It says, what two binomials multiply together give you the polynomial? You guys, every time we start with a polynomial and we get two binomials. So it's basically doing the same thing. It's just another way of asking you to factor. So our a value is 1. So we're going to go what plus what equals 8. And what times what equals negative 9? Well, you have to get a negative 9, but a positive 8. So one has to be negative and one has to be positive. So you want to get a positive 8, so the 9 needs to be positive and then the negative 1. You can't use 3 and negative 3 because that wouldn't work. It would just cancel each other out. So your two binomials would be x plus 9 and x minus 1. Okay, last problem. It says the area of an elevator is 30 square feet. There is one more foot tile on the length than the width. Draw a picture of the elevator's floor and label the dimensions. So my area is 30, so I'm going to draw my rectangle. There is one more foot tile on the length. So our width is just going to be x. Then our length is going to be x plus 1. So to get this is area. So if you guys remember, area is our length times our width. So we're going to have x times x plus 1. And this is going to equal 30. I'm going to show you how to solve this. We're going to get more in depth to it here in the next couple days. So you first have to distribute. So you get x squared plus x equals 30. And then you want to subtract over your 30. So you get x squared plus x minus 30. And that equals 0. We can't forget that equals 0. And then we know how to factor this already. So what plus what equals 1. And what times what equals negative 30. This would be 6 and negative 5. So you would have x plus 6 and x minus 5 equals 0. So then you would have to take each part, x minus 5 and x plus 6, and set it equal to 0. You would get x equals negative 6 or 5. You guys can't have a negative, so your answer would be 5 for this. And then we'll go into more depth on how we utilize that. So that's kind of doing all the steps we're going to be doing eventually. I just want you to be able to set it up and at least get it into this form right here. And if you can factor it, that would be awesome. Okay, let me know if you have any questions and you guys can get started on your homework.